For the next example, something slightly awkward happens, which is that doing integration by parts once doesn't quite get us to the point where everything is solved and sorted. It gets us closer, but not completely there. This is what's going on. I'm just going to, again, we're going to jot down that the integral of u dv by dx is the same as uv minus the integral of v du by dx. And I have x squared multiplied by e to the x, right? And what we saw in the previous example was that if I choose u equals x squared and v equals, or dv by dx rather, equals our e to the x, therefore du by dx equals, this may work, or maybe I need to choose the other way around, and I need to just kind of play around and experiment with this and see what's happening. So this seems like a sensible starting point. We may need to swap them like we did with the ln x. Let's just see where we get to. So if dv by dx equals e to the x, well, one of the nice things about e to the x is that it doesn't change when we integrate or differentiate. So v is also e to the x. And if u is x squared, then du by dx is going to be 2x. Now this seems positive to me because as I look at this, my uv term is just going to be x squared e to the x, that's no problem. And my v du by dx term is going to be e to the x multiplied by 2x. That is definitely simpler because it doesn't have an x squared in. But it's not simple because integrating 2x e to the x has exactly the same problem as integrating our starting point. We don't know how to do it. Turns out though, if I swap these around and do e to the x here and x squared here, I actually get worse, not better, because I end up with a cubic and it doesn't get better at all. In fact, it's much more complicated. So this is the correct way around to do it. And what that tells us is that the integral of x squared e to the x is equal to uv, which is x squared e to the x, minus the integral of v du by dx, which is going to be 2x e to the x. Just my dx there. And this is better, but it's still not there. However, what we can do is we can just have a look at this and recognize this is still a product of two terms, and therefore I can just reapply integration by parts. So I'm just going to draw a little line under that, and I'm going to start over with just this thing, integral of 2x e to the x. And if we begin again, I can say, well, u is 2x, v is e to the x because our dv by dx is e to the x, and when we integrate it doesn't change anything, and du by dx, this time it's just 2. So that means that this thing is equal to uv, so 2x e to the x, minus the integral of 2 e to the x. And that I absolutely can integrate because it's just a multiple of e to the x. So what we have after all of that effort is that the integral of x squared e to the x is equal to, and then let's just remind ourselves what we got to, it's x squared e to the x minus this new integral. So it's x squared e to the x minus, and then this new integral, we've applied parts to it again, is this. So that's minus 2x e to the x, take away negative, so it's plus the integral of 2 e to the x. And now what I have is two terms which have just fallen out from our method, plus an integral that's easy to do. So I have x squared e to the x minus 2x e to the x plus, and then what's the integral of 2e to the x? Well, it's just 2e to the x. Actually doesn't change at all. and then I need a plus C, I need my constant at the end. So I've done it, but I had to apply integration by parts twice. After the first time I had something slightly simpler, but it was still a product that still needed reworking. So the second application of integration by parts completely tidied it up into something I could just directly integrate. And that is not unusual, especially because those polygons, every time you differentiate, the power comes down by 1. So polygons will just get simpler and simpler every time you apply this process to them. It doesn't always mean that's how you do it, but it certainly is often a good strategy. And if you see that the first application has made life easier for you, it's not a bad call just to do it again and see if it gets better again.